Good afternoon. Can you hear me?
Yes, sir.
Yes, sir.
Yeah, so we can start the session. However, the attendance is not that good because the registered student is around more than 100. So then I think others will join while we are doing the session. Okay, so our course is data access and signal processing. PHU 5303. I think you all have the access to OLMS. Is there anyone got access to OLMS? Is there anyone? Or did you go through the OLMS? Did you check the login? Huh?
Yes, sir.
Okay, so you can find the, I think I have shared the information sheet. So you can find the information sheet and others as well in the OLMS. So second, I share the screen. Uh, can you see the screen? The OLMS page?
Yes, sir.
Just tell me. Yes. Can you see it? Okay, I just go through the syllabus. Right. You can see the screen now. I'll just take this to our document. So give me a second. So yes, I think you now you can see the syllabus of this course. Can you see it? Just tell me.
Yes, sir.
Okay. So these are the topics we are going to discuss, right, under this course, right? So you can find this information sheet and also the syllabus, everything, past papers, uh, assignments, assessment, and also the final exam papers, everything in the OLMS. So please go through the OLMS and all the updates, right? The Zoom links, everything recording will be uploaded to the Google Drive and share with the OLMS. So these are the topics we are going to discuss today onwards, right? Uh, uh, Today we'll go through the first two sessions, day one, right? And when you come to, once we completed up to 10, so actually this is related to our cat 1, right? And rest of the part up to 20 around think it should be around 20. That is the cat 2. So we have around 4 or 5 additional to I think up to 20. Okay, up to 20. So rest of the part, including the rest of the part, up to 26. I think it's 26. So for the final examination, right? So the mark calculation, the allocation marks, allocations, everything are given in the information sheet. So if you have any doubt, you can contact me and discuss about the issue, right? So these are the topics we are going to discuss. However, some of the topics we are not discussed. For example, delay lines, and I'll inform you. I'll when you are discussing the sessions, I'll let you know, right? So these delay lines will not be discussed, right? 1 or 2 sessions will not be discussed. Other than that, we are going to discuss everything, right? So these are the things I wanted you to say at the beginning, right? If you have any doubt, you can raise your question. And the oral mark calculations, I think you all are familiar with these calculations. 40% come from the CAM or CAM, and 60% from final marks, right? So this is the way we are calculating the final marks, right? Grades. So actually, this is theoretical course, no practical session. But when you come to level 6, I think it's level 6. Yes, you can find another course related to practical physics. So then all the theories will be discussed under this course, and the practical will be on that practical physics course, right? So no practical for this course. If you are going to do the practicals, it should be in under practical physics, right? So today, actually, sessions, I don't know the possibility to cover up to 3. However, we'll cover other 2 sessions, first 2 sessions, right? So these are the topics we are going to cover today, right? And the attendance is very low. However, others will join while we are doing the session, right? So these are the learning outcomes. Actually, once we finish the session, so you should be able to describe about the principles of transducers and the fundamental concept of data acquisition systems and their importance in various fields, right? And the architecture, the component of typical data system, right? So these are the things we are going to discuss, right? So when you come to the first session, you all have received the course material, isn't it? Did you receive the course material,
Yes, sir.
the books?
Yes, sir.
Just tell me whether you have received the course material or not. You got, okay, great. So okay, so right, some of you not okay. You didn't receive. Just tell me the center name. Few of you have not received the course material. Okay, it is okay. Actually, if you can go through this lecture series, others the day school series, that is also enough. But I'm recommending you to go through the course material as well in order to improve your knowledge, right? CRs also not received, but I think books are available. However, tomorrow I'll check uh, the availability, and uh, so then you can collect the books. What about other centers? CRC, okay. MRC, KRC, JRC. Did you receive the course materials? Other centers, students from other centers?
Yes, sir.
Okay, okay. And so I'll check the availability and inform you through. Okay. What is the center? What's your center? Center name? MRC. Okay, MRC. Okay. So
KRC also.
it's okay. Okay. What about others?
BRC, okay.
CRC, I think. ARC.
Oh,
ARC. Okay.
MRC,
ARC
okay, sir.
students, you didn't receive the course materials. Okay. So okay, yeah, you can contact me. So just tell me, right? So then I'll check and solve that issue, right? However, it doesn't matter. If you can go through these slides, that is also enough. But it's better to improve your knowledge. That's why we need. And also, before we are going to start the session, otherwise, before the scheduled session, it's better to go through the course material, right? So then if you can take parts, you can't understand, you can ask questions, discuss. So now we can start our first session, um, introduction to data acquisition system. Data acquisition system. So can anyone tell me what do you mean by data acquisition system? Term data acquisition, data acquisition. What do you mean by data acquisition? Can anyone tell me? Huh? So what do you mean by data acquisition? I hope you all will actively engage in this session. So please respond the questions. It is okay. I'm asking about your understanding. If you know the exact meaning, it is okay. If you don't know, it is okay. But I'm expecting your answer, response only. Yes, yes. Anyone? Others, you can use your textbooks as well. Right. Yes. Okay. You know, handling. Handling means yes. Which type of things you are going to handle under data acquisition? What about others? Huh? What do you mean by acquisition, data acquisition?
Data gaining system.
Yes, exactly correct. Data gaining system. Yes. What else? That is good answer. Data gaining. Yes. Actually, we have to collect data from different locations. We need to deal with. We need to uh, find data from different instruments, different sensors, transducers. We will discuss the meaning of the transducer in detail, right? Sensors. However, we need to access the physical data from different physical quantities, maybe temperature, pressure, otherwise humidity, right? We need to collect data, right, from different locations. So, so then we need to yes, we need to collect and we need to measure this data from different location, different instruments and other devices. So data acquisition, we can say it's a process of collecting and measuring physical or electrical signals. I'll write it for your understanding, right? Data acquisition is a process of collecting and measuring a physical law or electrical signal. Signals from sensors, instruments, or different devices, other devices, just say other devices, right? So actually this is the process of collecting, as you say, that is correct, exactly correct. Gaining data, yes, grabbing data, collecting data, and measuring physical, maybe physical quantity, maybe others electrical signals from different sensors, instruments, or other devices. So this is called data acquisition, right? Data acquisition. Okay, now we know what is data acquisition, right? Try to understand enough, right? In some of the cases we need to know, you have to reflect your knowledge, but try to understand, so then very easily you can keep the things in your mind, right? So then we know our course name. What's our course name? There's a data acquisition and signal processing. Signal processing part also there. So why we need to process the signal? We mean, we know we measure the data, we collect the data as electrical signals. Or why we need to process these signals coming from different locations? I'll say that is the, just say it's data, the signal processing. Signal processing. Why we need, what do you mean by signal processing? Otherwise, what is the meaning of this signal processing part? Anyone? What are the things should be included under the signal processing? Can anyone tell me?
Convert analog into digital.
Exactly. Yes. Analog into digital conversion. Others we call it A to D conversion. What else? Yes. Okay. We can discuss in detail about analog to digital conversion. Right. Okay. Actually, once we grab the data, once we collect the data from different sensors, when you are going to collect the data, we can consider it as electrical signals. So, okay. So we need to analyze this data. In some of the case, these signals not that much enough to measure. So then we need to amplify the signal. So we call them process. We have to process the signal. So signal processing involves, we can say involves the manipulation and analysis of acquired data okay. So this is the so we know it will improve the quality of the signal, that is the data, right? So that's why we need data acquisition system, right? That's why we need data acquisition system. So we need to process the data, we have to grab the data, so then we need data acquisition system. So we should know about the main component of the data acquisition system. This data, the system consists different components. The first one, transducers, then signal processing circuits, and A to D conversion, as you said, the A to D conversion circuits, right? And however, we need to connect the system with the computer. So we need computer interfacing part as well. After that, we have to process that using the central processing unit, right? So these are the major parts of data access system. The transducers. Can anyone tell me what do you mean by transducer? Transducer. Huh? The sensor. I hope you all will engage with the session. So I'm not asking names, but please, if you know anything, so just tell me, right? Till this engage with the discussion. So I'm asking, what do you mean by transducer? There's just take a sensor. What do you mean by a sensor? Hmm? What do you mean by a sensor? Okay. Others, you can use the chat box just to express your ideas, right? If you can, it's better to use the microphone. Otherwise, it is okay. Just use the chat box, right? Okay. Transducers. The first part is transducer, and the second part is second component is signal processing circuit, A to D conversion. We can discuss each component in detail, right? So, then this component, we have 5 components here. So within these components, we can discuss about the data access system, right? You can see the schematic data access system, right? This is the schematic, right? So we know the system under measurement. We have different measurements. We need to do different measurements, maybe physical quantities like temperature, pressure, humidity, right? So there is a system we need, right? System of measurement. So we need input transducer at the beginning. So this is the input part, input transducer, right? Input transistor. Right? We have 5 components. Okay, transducer mean can be input to output, right? Input to others output. Transducers can be input to output. So here we can see input transducer and also the output transducers, right? And then signal processing electronics, right? In the both sides. So first grab the data. We need signal processing, and if you need to control output, just like actuators, right? So we will discuss what are the actuators. We need this output. There's the signals, controlling signals, right? So that's why the direction change. You can see first grabbing the data to the computer, then after that if we need to control, so we need the data coming out from the computer, right? That's why we need thematic. We can see the second, this is the first part. This is the transducers, right? Transducers, right? In the second case, we can see that is processing part, right? Processing, signal processing in electronic, right? Then A to D conversion. Why we need this signal processing before the A to D conversion? Just say some of the signals can be interfered with noises. So before we are going to do this conversion, A to D, analog to digital conversion, we have to filter the signal noises, right? We need the proper signal without noises. So we can process the signal. We call it noise to signal ratio, noise to signal ratio, right? I'm asking one other question. If you need a good signal, just tell me whether we have to increase the noise to signal ratio or decrease the noise to signal ratio. Huh? We have
Increase.
increase, yes, increase. Just say we have sine wave signal and we have some noises on the signal, right? If you can increase the noise to say ratio signal, sorry, noise to signal ratio, right? We can neglect the noises, right? If the signal is high compared with the noises in amplitude, so we can neglect the noises. So before we are going to do A to D part, A to D conversion, we need to process the signal like noise, increasing into signal ratio and also the signal amplification we can do, right? Different discriminations, right? We will discuss, right? We will discuss about them, right, in detail. After that, we have to do this A to D conversion. Just tell me why we need A to D conversion. Analog to digital, we know analog signals. We know analog signals. Well, if you consider signals, we have two different signals, analog and digital signal. If it's analog, it's a kind of continuous signal. But when you come to digital signal, we have discrete levels. Otherwise, if you consider two levels, right? We have discrete levels, not continuous. So this is the difference between signal, the analog signal and the digital signal. So just tell me why we need this conversion. Can anyone tell me what's the reason behind that? Why we need this conversion, A to D conversion, when you are doing the signal processing or data acquisition? Can anyone tell me what's the reason behind this? I'm asking why we need analog to digital conversion. Huh? One is responding.
For good quality.
Yes, we need to improve the quality. Okay. What else? What should be the purpose? Yes, when you do this, we can improve the quality as well.
Reduce some noises.
Yes, the noise reduction also can be done. Right? There are some answer in the chat box as well. CPU reads digital signals. Exactly correct. Right? CPU, yes. Computer only know 10. Yes, another answer. Right? Good. So that means uh, when you come to the analog signals, it is not possible to handle with the computer. As you mentioned, computer knows only 10. So then we have to convert that signal into analog signal into 1010, mean digital part. That's the reason we need A to D, right? A to D. But when you come to a radio receiver, TV receiver, so on that analog, we call it analog broadcasting. That is, yes, analog broadcasting. It's possible, but when you come to this data acquisition, we need A to D conversion because the computer will understand digital signals only, right? That's the reason, right? You know, all the measurements are analog in nature. So then we have to do this conversion, right? So that is the reason behind this conversion. So then we need to know about transducers. My first question was regarding the transducer. What do you mean by transducer? So transducers, you can see here the transducer, about the transducer, right? Transducer is a device that convert one form of energy into another form. In energy transition is there, right? Energy transfer. transferring energy, one form to another, right? Okay, okay. So when you come to transducer, the transducer are converting energy from one form to another form, right? That's the there's an energy transition, one energy form to another energy form, right? For example, if you're going to measure the temperature, that is the, just say it's temperature, right? That means heat. That's the energy. The heat energy, say it's heat, thermal energy, right? And if you consider, if you are going to measure the temperature, we can think about a sensor, transducer, right? Let's say LM35, or there's a chip, semiconductor device, right? A sensor, right? So that detect the temperature, thermal condition, there's thermal energy, and convert it into electrical signal, right? Electrical signal. So that is the energy conversion, thermal energy into electrical energy, electrical signal. So that is the main function of the transducer, right? I'm asking one other question. Can anyone tell me what do you mean by a sensor? So um, uh, and then we can compare the transducer with the sensor. What do you mean by a sensor? That is, what is the main function of a sensor? Can anyone tell me?
It is sensitive for specific kind of data.
Oh, sensitive for, I mean, physical quantities. It's sensitive to special type of physical quantities.
Yes.
Okay. So what do you think about the energy? I mean, the principle. I mean, energy transfer. I mean, when you come to the transducers, we can say one form to another form, energy transition. So when you come to the sensor, how we can explain the energy transition? Energy transferring also should be there. Hmm? Actually, when you come to a sensor, right? Sensor. Normally, can anyone tell me? Yes, answer, one answer is there. Yes, physical to electrical. Exactly. If you consider a sensor, right? If you consider a sensor, right? Physical, whatever energy, right? Physical quantity, physical energy, whatever, maybe heat, whatever, right? Otherwise, sound, right? Whatever energy should be transferred to electrical energy, right? That is the main function of a sensor, right? Function of a sensor, of a sensor. What is that? Whatever the energy mode doesn't matter, it should transfer into electrical energy. But when you come to a transducer, uh, the energy form of the energy is not specified. Whatever the conversion should be there. So sensor also a transducer, right? Sensor also can be considered as a transducer, but all the transducers are not a sensor, right? All the transducer are not a sensor. Especially when you think about an actuator. So output is not an electrical signal. It's mechanical motion, maybe motion, otherwise mechanical signals. So when you come to actuators, actuators is also a transducer but not a sensor, right? So if we can understand this difference, that is enough, right? Just read the things given here. In general, transducer is a device that converts one form energy, convert one form of energy to another form. That's the important fact, right? Actually, I want to say that normally I'm sharing the recordings. This recording will be shared on OLMS, and also whatever I am writing on the screen will be shared with you, right? So don't try to write the things given in the screen. But if I ask you to do calculation, otherwise, if you need to make a short note, it is okay. Because I am going to share this whiteboard writing and the slides with you. I have already shared the PowerPoint presentation with you actually, right? With just find on OLMS and whiteboard writing. This writing also shared with you, right? Okay. Okay. But in computerized data acquisition system, transducer convert various physical variable into electrical signal. Physical. When you come to the computerized data acquisition system, right? Transducer convert various physical variable into electrical like sensors, right? When you come to computerized data acquisition system, but normally transducer, the function is given here, right? Energy transducer, right? Is that clear? Is that clear or not? Is that clear?
Yes, sir, clear.
Right, great. So then we can move to the classification of transducers, right? Classifications. So we have input and output transducers. We have already discussed about the input and output transducers. And actually, when you come to the data acquisition system, the architecture, here you can see the semantic. So here the input and output transducers, right? So however, input transducer can be active or passive, depending on the application. We can find different sensors. Input and output transducers, active and passive transducers, right? So input and output transducers, we know the input and output transducers. For example, input transducer, can anyone tell me an example of input transducer?
Photodiode.
Photodiode. Okay, correct. Photodiode. Output transducer. Can
Light
anyone tell? Sorry.
light bulb.
Yes, bulb. Exactly, bulb. Exactly. So photodiode is input transducer and output transducer. You know that input or output speaker.
Input.
Speaker.
Output.
The output. No, it should be output device. Output transducer and microphone.
Input.
Input device. Input transducer. So this is clear. Input and output you can very easily understand. So active and passive transducer. What do you mean by active and passive transducer? That is the next important thing we should discuss. Active and passive transducers. Have you heard about active and passive transducers? Here is about the input transducers. We can go to first. We can complete this slide. We have discussed about it. Input transducers are used to sense the physical variable in a system. Physical variable, maybe temperature, again pressure, like the light condition, right? therefore called so sense the physical variable, right? Therefore called them sensors, right? Input transducer are called sensors. We have discussed about the sensors actually, sensors, right? So as you mentioned, the photodiode, the thermocouple like output transducers are used to control the physical
The audio
variable.
clear na.
They called
The audio clear na.
family. What is clear? I see.
Clear na sama kedi kedi.
Okay. Give us right. How about now? How about now? Am I audible clearly? Right. If there is an issue, just tell me, right? Okay. So when you come to the input and output transducers are sensors. Most of the cases it should be sensors because input mean we need the signal to process. So then transducer output, if the output of a transducer is electrical signal, that is right. Output transducers are actuators. No. They can be actuators, right? Actuators mean um, uh, however there should be a moving part, mechanical part, right? So like a stepper motor, here it's given stepper motors, right? Stepper motors and speakers, light bulbs, right? So then those are called actuators, right? However, we need to know about the active and passive transducers as well. The second category classification, active and passive transducers. If you have a book, just tell me what do you mean by the course material, and you can find it. Active and passive transducers.
Produce their own electrical.
Active mean yes, they yes, exactly correct. Produce their own electrical signal without having a external source. That is active. Active devices. Passive mean we can move to the next slide. Active transducers don't need power source. Keep it in your mind. But just read the course material. Is it mentioned the same or different? Just check the course material. I think at least one or two can check. Is it given the same understanding or different?
Different.
In the opposite, no? But just correct it, right? This is the correct one, right? So just do this correction on the course material. Active transducer don't need any external power source, right? Active transducer are self-generated. We call them active transducers. Active transducers, self-generating. Self-generating. We call them self-generating devices. That means they don't I'll write it. They do not require an external power source. Right? No need external power source. Okay. He also mentioned the correct way, but correct meaning. But in your course material, if it's mentioned it's required external power source, just correct it. Make this correction, right? They produce electrical signal by their own absorbing energy from system of measurement. right? System of measurement. That means if you are going to measure the temperature, it absorbs the temperature, thermal energy, and vibrate within the vibration, it will produce a current flow, right? So you should be able to understand this main difference between active and passive transducers, right? Actually, it's dependent on their power requirement and how they generate output signals, right? Without having external power source, if they can self-generate their signals, that those are called active transducers. Otherwise, we call them passive, right? However, yes, we can think about the examples as well. Photodiodes, thermocouples, piezoelectric devices, right? If you need more details regarding this, just surf on internet, the piezoelectric, right? However, actually, piezoelectric effect, I mean, if there is a vibration on that device, right? Here you can see that, right? You can see this on this figure. Uh, so just say this is the piezo, right? So when you are going to connect it into a voltmeter or a circuit, right? If you have a proper closed loop, so then within the vibration, if you have if it experience the vibration stretch, so it will absorb that energy and it produce a electron flow through this loop, closed loop, right? So that is the piezoelectric effect, right? And also, if you think about output device like piezoelectric actuator, just say a microphone, right? Microphone, not a condenser microphone, but piezoelectric microphone. So again, sorry, actuator. This is actuator actually. This actuator, the first one we can say it's a kind of microphone, like a microphone, right? Second one like speaker, right? Speaker. So because of this vibration, it will produce a current flow, right? But in first case, you can see that with that stress will recognize and absorb that energy and produce a current flow. So that's the difference between this uh, actuators and the sensor. Otherwise, you can see it's kind of microphone, right? Actually, when you come to this piezoceramic devices, the range, the microphone, if it's a microphone, the frequency range is high compared to the condenser mic, right? So we can discuss in detail about these microphones and also the condenser mics, piezoceramic, right? Microphones, transducers, right? In detail. So these are the things I need you to discuss about the active and active devices, active transducers. So you should know the meaning. What does it mean? Active transducers do not need any external power source. That's the important thing. And also when you come to the passive, right? Passive. So passive transducers need external power source to produce the electrical signal, right? They change electrical parameters like resistance, right? That means passive like LDR. LDR mean, can anyone tell me what is LDR? If you can see, if I remember correct, this kind of figure, exact, you can find it on the internet. What do you mean by LDR? What does it stand for? Light? Anyone? Light dependent resistance. Light dependent resistance means if the light is incident on the LDR, the sensor, it will reduce the it will reduce the resistance. So then you can say light drop resistance, but the meaning is light dependent resistance, but we can say light drop the resistance. Because of the light, the resistance is dropped between two terminals of the LDR, right? So then we can connect this into circuits because the resistance change can't be detected, right? So because of the resistance change, we can change the voltages. So so we need external circuit, external voltage source to detect the light condition, right? So we should discuss the type of external circuits as well. However, when you come to passive circuit, passive transducers require external power. Passive requires external power, right? Not self-generating. It's required external power. They need, we can say here it's given, I think, passive need external power source to produce electrical signal. Those are also sensors, but because it's producing electrical signal, but they require external power source, right? So okay, okay, we can think about examples, few examples. Here it's mentioned resistive thermometer, strain gauge, and condenser mic. Condenser mic also there, right? So condenser mic mean here actually I think it's given the figure, the condenser mic. You can see the figure of a condenser mic, I think, okay, which is connected to external circuit. You can see source of waves. It will transfer the energy to the sensor transducer, and you can see diaphragm. What do you mean by diaphragm? Can anyone tell me what is this diaphragm? If you are doing bio or zoology, I think you have heard this diaphragm. Actually, it's moving plate, no? It's moving. And here we have back plate, right? So if this plate is moving with the vibrations, so the gap between this diaphragm and the back plate is changed. So we know C mean the capacity. C equals A epsilon over D, right? So then if you are going to change this distance gap between these two plates, diaphragm and the back plate, so we know the capacity will be changed, right? The capacity will be changed, capacity of the condenser, actually the capacitor. So this two plate capacitor, parallel plate capacitor, and because of these vibrations, this gap between these two plates is changed, right? So that's the basic principles of a condenser mic, but totally different when you come to the transducer, what do you call it, piezoceramic transducer, piezoelectric transducer, right? Piezoelectric. So then because of this voltage and we have resistance, so we know the IR product will be changed. That's the voltage. Resistance change mean IR product. So resistance is constant. Current is changing because of this capacitance change, right? Even the voltage also can be changed. So IR product will be changed, right? Finally, this current value will be changed. Therefore, IR product will be changed, right? So that's the way to obtain grab the signal from this kind of devices. We need external power source, power supply, right? Is that clear? Is that clear or not? Is this clear?
Yes.
Right. Okay.
Yes, yes.
So here you can see the photodiode. One example is photodiode. You know, it's produce a voltage when the light is incident on the photodiode, like LDR. The difference is LDR, it is not producing voltage, but resistance change, right? Thermocouples. When you come to the thermocouples, it converts the temperature difference into a voltage, right? Converts the temperature difference into a voltage, thermocouples, right? So, piezoelectric devices are the sensors will generate voltage in stress or strain, right? Examples that photodiode, thermocouples, and piezoelectric devices, right? So we can move to the next part. That is circuits used with passive sensor. Passive sensors. Second. Okay, right. So then, okay, before that, we can summarize this. We can summarize the things that we have discussed, right? They say active transducer, and also a passive transducer. So then, how about the power source? Just tell me, what about the active transducers? It's required or not? Power source. We can summarize using a table. Power
Not
source.
required. Not required, sir.
Not required. But when you come to the passive transducers, it requires external power, right? And so what about the output signal of the active transducer? It is generated from the input energy, right? System of measurement. It's absorb the energy from system of measurement. So you can say generated from the energy, output signal. We can say it's generated from input energy. You know, the energy is absorbed with the active transducer, input energy. But you know, when you come to the passive signal, passive transducer, it it uses external signal, that is external voltage. So we can say it modifies external signal, right? External signal. So what else we can say? Okay, so examples, we can think about examples. Can you tell me the examples for the first part? Active transducers, thermocouple, otherwise piezo electric sensor, And when you come to the passive transducer, we can think about, we'll discuss in detail the examples in details. Strain gauge, otherwise potentiometers. Right? So when you come to think about the complexity, others complexity. So active sensors, which one is simplest form? Just tell me. Complexity is less so high in when you come to the active sensors.
Yes.
Yes, it's simple form. But when you come to passive, because we need external circuits, it's more complex, right? More complex. So these are the things you should know, right? Actually, when you come to the output signal, it's generated, but when you think about active sensor and transducer, the signal strength can be weak, little bit weak compared with the passive transducer, because it's having external power source, right? So these are the things you should know, right? Okay, shall we move to the next slide? If you have any question, you can raise, right? Circuits used with passive sensors, because we know that external circuits we need, external source we need. So then we can think about external circuits, right? So before we are going to discuss this part, I think we have a few slides to discuss. Yes, summary. Okay, once we finish, we can have a break, small break. Right. So then we can think about this. Okay. Right. So say circuit used with passive sensors. Circuits used with passive sensors. Right. So we know if we are going to use passive sensors, we need external power supply, power source, right? So it will just read it. Since the passive transducers are unable to produce signals by themselves, the same thing is mentioned here. They are embedded in following two circuits, right? When it's producing the sensors, transducers, embedded circuit also there. Why we need embedded part? We need to have this voltage, external voltage source. So then we can't directly connect that external source. We need some circuit, right? So maybe voltage divider circuit or bridge circuits are embedded with the passive transducers when they are producing, right? Generally, their resistance, capacitance, or inductance is changed following the variation of physical variables. Do you remember that we have discussed about this one, the microphone, the passive transducer, condenser microphone. So the parallel plate capacitor is there, diaphragm and in between the diaphragm and the back plate, the gap is changed, gap is there. So when the sound waves is incident on the condenser mic, so the diaphragm will move, otherwise oscillate. So because of this oscillation, the gap also will be changed. Variation is there, right? So we can find the variation of the signal because of this power source, right? Otherwise, that variation is the capacitance. But when you are going to apply this source, we can take the output as the current flow, right? This voltage variation. So that's why we need the circuit, embedded circuits, right? Embedded mean we have to include the circuit inside of the same chip when they are producing, right? So right, next part. Right. So there are two types of circuits we have to consider. That taking the in the previous case capacitance and also resistance when you come to LDR and inductance also measured, right? That variation will be measured in the passive sensors, right? So those are the physical, depending on the variation of the physical variables like temperature again, there's humidity. So we can measure this resistance and these quantities, capacitance and inductance, depending on the variation of physical quantities, right? So we need external power supply embedded with this circuit, right? Voltage divider circuit and bridge circuit. Just so then we can move to the voltage divider circuit, right? You should be able to prove this equation. Actually, this is not that much complex, very easy equation. However, this is related to the potential divider circuit. If you are not that much familiar, because I know some of the students they are doing this course, but physics they have not followed physics subject. I don't know, some maybe some of the students they others minor subject is physics. So however, uh, if you can go through these sessions, you have to attend on the session, and others just refer the course recording, course materials, right? Very easily you can uh, get a good grade for this course, right? There are mathematics as well. There's some calculations as well, but very easily you can do them, right? However, electronics and mathematics are the major components of this course, right? So you some of the questions, if you go to the CAT papers, you asked to prove the equations. Otherwise, you have to find the transfer function. Transfer function, right? So for voltage divider circuit, we have to find V output. Otherwise, we are V in. That's the transfer function. So how we can find it? This is a potential divider, right? Potential divider. So we can take the summation of the resistance R1, R2 in the denominator, and the numerator, it should be the resistance measured from the zero voltage level, right? Then you can multiply it by this voltage level, V, right? So that is the way to obtain the this one. So however, when you think about the theory, this is the circuit, no? This is the circuit R1, R2, and V out, right? Here V out, we have V out, and V in mean this is the voltage we have, right? So because of this V in, right? V in mean actually it's like a voltage source, right? V in. So there is a current flow. There is a current flow. So if you know the current flow, V out should be equal to what? Just say it's I. V out should be equal to what? Just tell me what should be the value for V out. The voltage in between resistor R2. V out should be equal to I into
I
what?
into
R2.
R1
Exactly correct. Okay. So if you can find I, how you can find I value? Just apply Kirchhoff for voltage V equal IR to the circuit. So I equal V in divided by R1 plus R2. So what we have to do? Now we know this I value. This I value should be substituted here, right? We note I R2 equation. So V note should be equal to V in into R2, R1 plus R2. That means we can rearrange this equation like this, right? So this is the way to obtain. Actually, directly you can write it, no problem, right? You can write directly. How we can write directly? V out equals V in divided by the summation of resistance, right? V in divided by the summation of resistance, and you multiply by the resistance value which is connected to the ground, right? So then very easily we can write this equation, and this is the way actually, theoretically, this is the way to obtain the equation. However, no need to follow these steps, right? You can directly write the potential divider output. Is that clear?
Yes,
Is this
sir.
clear? Okay. Right. So then we can move to the next. This is the voltage divider circuit and the bridge circuit. Bridge circuit. So when you come to the bridge circuit, this kind of circuit we call it bridge. Setu paripathak කියලා කියනවා. Bridge circuit, right? Bridge circuit. So here we have yes, R, resistance R. There are 3 R resistance and RT. RT can be thermistor or resistance, otherwise LDR, otherwise thermistor, which is changing with the resistance is changing with the temperature. That's why we use this RT, right? RT, T for maybe temperature. The other is thermistor, resistance of the thermistor, right? Right. So how we can obtain this V out? Can you do this one, this example? I'll give you a couple of minutes to do this question. Now, yes, I'll give you couple of minutes to do this question. This proof, I just do within 1 or 2 seconds, 2 or 3 minutes. So I'm asking you to prove this one. This is the V out. V out is given in between the voltage in between these 2 points. How we can prove this? I'll allow you to do this question within 2 or 3 minutes. Just do it. So any question, just raise your question, and while doing the okay, just do it after that. I'll ask you to do the next. Okay, so are you doing this? Well, කරනවද මේක? Huh?
ඕකට මේ voltage divider branch දෙකක්
Oh.
subtract කරන්නනේ තියෙන්නේ.
Oh, ගත්ත dance එක ගන්න බලන්න. Actually, yes, that's the way you have to follow. Here we have we have to find that here actually V out mean here we have V1, V2. So V1 minus V2, voltage difference. So then V1 you can find, how we can find V1? Using the potential divider circuit that we have discussed in the previous slide. V1 mean V in divided by RT plus R into R. Just say it's R, right? V2 should be equal to what?
V
V2
in
should be
by
yeah,
half
V in divided by
2
2R. R plus R mean 2R. Yes, 2. Yes, 2. I just multiplied by R. So then R will be cancelled out. Here the R are cancelling out. So V in minus 2. So over 2. So then we can find V1 minus V2 mean V in R RT plus R minus V in for 2. So we can say V in is a common factor. V in R divided by R plus RT minus half. So we have obtained the equation. If you go through the CAT papers, the final exam papers, in some of the questions you can find the same, right? Same calculation you are asked to do, right? So please practice this. These are not that much difficult. Very easily you can earn marks for the CAT examination. And I want to say at the beginning, so if you are willing to get a good grade, so please try to go through the CAT 1 and CAT 2 papers with highest mark, right? Then very easily you can obtain a good grade, right? If you have any doubt, you can contact me anytime.
Okay.
Sir, do you upload handwritten things to? Yes. Today itself, I'll upload everything to the OLMS, even the whiteboard handwritten as well, right? So then when we are discussing, try to understand everything. And if I ask you to do something, you can write. And also, if you need, make a own note while at the session, right? And don't put off until tomorrow to go through the things, right? You have to do it today itself. Otherwise, if you have any schedule today, so just try to do at least tomorrow, right? Because then only you can keep the things. You have to reflect the things, right? You have to reflect the things. Reflect means you have to go through the things and check whether you have in the real competency on the theories, right? So that's the way to reflect the things. So is this clear or not?
You can write this.
Yeah, sir.
Right. So then we can move to the next slide. So it's discuss the measurable physical variables,
What is
systems of measurement. So if I move to the first part, this one, the schematic, right? So this is the transducer part we have discussed, and the system of measurement. So if you think about the system of measurement, we have different physical quantities to measure, right? Visible variables, they are changing with the time. The different condition it's changing. Temperature, displacement of force and weight due to stress, strain, light and radiation condition, light condition, the pressure, humidity. So these are the measurable physical variables. So in order to, if you need the measurement of these variables, you should have sensors to detect, right? Electrical sensors, electronic sensors. So these are the things that we are going to measure, and we need data acquisition system to measure these physical variables, right? So this is a summary that we have discussed so far, right? This is a summary. We have first physical variable, second, third, fourth, fifth, sixth, and seventh. There are seven variables we are going to discuss, right? And we have input transducers, that means maybe active or passive. Output transducer, actuators, we call them actuators. That is a mechanical part. So temperature, we know we can detect with thermometers, right? So we have detectors like thermocouples, right? thermocouples. And when you come to the passive, if you can't understand any of these devices, just tell me, right? I'll explain. Resistive thermometers, PN junction thermometers, right? So those are passive devices because we need the external power source to external power supply to measure the values, right? And output, if you consider the temperature, output transducer should be heated, right? We can, it will heat, it will produce this, if you need water, hot water, so then it will produce hot water. So heater is the output transducer. So that is okay. So the second one, displacement, sorry, force and weight. Displacement, force and weight. So when you come to the these sensors, we have to think about active transducers. Those are piezoelectric devices, right? And if you think about passive transducers, resistive strain gauge, potentiometric resistive transducers, linear variable differential transformer, LVDT. Right, we'll discuss that as well. And stepper motor actuators. Stepper motor mean, do you know about the stepper motor? What do you mean by stepper motor? Anyone? Stepper motor කියන්නේ මොකද්ද?
ස්ටෙප් එකට move කරන්න පුළුවන් programmable motor එකක්.
Yes, exactly correct. So actually, if you are going to supply the energy, electricity to a motor, normal motor, so we can't control the speed. We need external circuit to control actually, otherwise we can apply different voltage to control them. However, we can't rotate, we can control, we can stop, we can, others we can, if we can rotate half of a cycle, it would be very important if you are going to develop different applications, some certain angle, right? So with stepper motor, we can rotate the armature, there's a motor for different steps, right? Stepwise, its rotation is produced stepwise, right? So stepper motor also a output device, right? Stepper motor is also a output device. Vacuum pressure pump. So we can reduce the pressure. So vacuum pump also output device related to the pressure. Right? Pressure. Light, if you take light, the physical variable. So photodiode is the active transducer, and LDR. For the photodiode, no, we no need to apply the voltage, right? A voltage device, but LDR we need. We have discussed them, right? And radiation, we'll discuss this Geiger counters, right, later in the next session. These are the active device and Cherenkov directors, scintillation directors, and also ionization chamber, proportional chambers. So these are the passive transducers, which requires external energy source. And also radiation sources are the output, which is producing radiation, right? When you come to the radiation part. Sound, microphone, and speaker is the output device, and condenser mic can be considered as a passive device, right? If you consider the microphone like a transducer, piezoelectric microphone, those are active sound transducers. And for the humidity, we have passive devices like capacitor devices and humidifiers, just to change the humidity. Those are the output devices, output transducers. So these are the things we should know as a summary, right? If you have any doubt, just raise your question. So then we can move to the, we have discussed about the first part, that is the first part of the semantic, that is input and output transducers, this part. So, right, this part. Okay, this part we have discussed. So now signal processing, then A to D conversion, right? Signal processing part, right? So, signal processing mean we have discussed about it a little bit, small discussion on it, right? Signal processing. Why we need amplifier under this stage? Signal processing. Why we need the amplifiers? Can anyone tell me? Why we need? What is the purpose of having amplifier?
To improve small signal to large signal.
Yes, we need to. If we have not a detectable signal, so we need to amplify them. Right. Great. So amplifier we need, and filters. Why we need filters?
To cut off
Filtering noises.
unwanted signals or noises.
Noises, yes, exactly. In some of the cases, we need to save the pulses as well. We have to save the pulses, right? We will discuss pulse shaping as well. And some in circuit, we have to, if we need to do addition of signals, so some in circuit we can apply, right? And also discriminators. Discriminators mean, just say if you have noises in some of signals, right? So we can define threshold level, right? Threshold level. So if some signal is greater than some certain threshold value, so we can remove this part, right? So then noises also remove. However, we can define the threshold high voltage and low voltage as well. So if you're going to think about the low voltage value, so low noises also can be removed. So discriminator circuits also will be discussed later, right? Within 2 or 3 sessions, we'll discuss this. We will complete this circuit as well. After that, final stage of the of our semantic signal processing part, right? Sorry, data acquisition. Analog and digital conversion. As we have so far, we have discussed about actually about the analog and digital conversion. So we know all the signals, physical quantities are analog in nature. If you are going to grab the signals, acquire the signals, so those are analog in nature. So we need to convert them into digital form, because we are going to feed them into a computer. Computers are working with digital signals only. And digital to analog converters are used to convert digital number into analog, thereby control output transducer. So if you need to program an actuator, that if you are going to work with the output device, we need to opposite transition, right? Opposite conversion. So then we can work with output transducers as well, right? So analog to digital and also D to A, A to D, right? We need to apply this circuits as well, right? We'll discuss everything in detail. Finally, we have to do the final stage is actually computer interface. If you can remember, I'll show you that schematic diagram. Final stage is computer interface, right? You can see here, right? Computer interface. So here is the computer interfacing part. Transfer of data to and from the central CPU is done through the interface.
Na.
Transferring data from or to from CPU, right? Just say this is the CPU.
30, 40,
Transferring data
50.
to or from, right? Here to and from.
Wow, what is
Maybe A to D conversion from coming from A to D conversion or however interface we need to deal with the CPU, right? So interface make the data transfer across it to act with data handling, addressing, handshaking, scheme of internal bus of CPU. So we will discuss about everything in detail later, right? So serial communication, others parallel communication, others USB, right? Computers are RS-232 serial communicate serial and GPIB port USB. It's available. So using these interfaces, we can communicate with the computer, in order to complete this data acquisition system, right? So these are the things coming under the session one. If you have any doubt, just raise your question. Otherwise, we can move to the second session. Start the session at 1:30 and stop time is 3:30. So we have half an hour. So just tell me if you have any doubt. Just raise your question. Huh? Is that clear? Everything is clear or not? Everything is clear or not? I'm reading your
Yes, sir.
messages. Yes.
Yeah.
Right. So these are the things I wanted to discuss at the beginning, right? So then we can move to the rest of the parts. We have half an hour and I'll give you 5 minutes break. Right, 5 minutes break. Just have the break and once you finish the break and just send your registration number, rate number, name with initial underscore, name with initials and center name. For example, 1 2 3 4 5 underscore name. Makari, it was initial dan initial and center name maybe CRC, ARC, whatever. KRC, right? So please send your detail to the chat box, right? Once you finish your have taken your break, right? You will be having 5 minute break. Okay, I think you all are here now. So, one question is in the chat box. Find it, I think one questions. Yes, so discriminators are kind of filter. I think yes, discriminators also can be considered as a filter. Yes. Uh, yes, here it's given in different topic in the category. I don't know. I don't know who asked that question. Just tell me whether it's clear or not.
Yes, sir. I mean,
Great. So then we can move to the next slide. If you have any doubt, just raise your question. Then only you will be competent on the theory actually. So actually at the beginning you will feel that we are having some very simple calculations. Even the two calculations we have done also not that much difficult. However, when you come to the Fourier series and there are some one topic session related to Fourier transform as well. So attending on the session is very important. At least you have to go through the recording, right? However, uh, hope you all attend all the sessions, Then I'll share the recordings, right? If you need to go through it again, so then you can have the recording. Okay, sensors for this is the second session. Normally, we will be having 24 sessions, right? When out of 26 or 7, we will do only 24, right? 24 sessions. So first day, I thought to discuss only 1 and 2, right? Normally the average is 1 and 2, but some of the sessions 3, 4, 4 sessions or 3 sessions will be covered. So within 10 days, 10 or 8 days, we can cover all the topics. But once we finish it, at least after the session, go to the lecture material and also the course book as well. If you can go through the course book as well, very quickly you can go through them because you can understand, right? You can understand very easily. Temperature sensors. We have discussed about temperature sensors. Actually, we have discussed sensors. So now we are going to move to temperature sensor, right? Temperature sensor. That means heat condition. The thermal condition will be detected. These sensors, thermal condition. We can use thermistors, thermocouple, and PN junction thermometers as well, resistance thermometers. Right? We know the when you come to passive sensors, right? When you come to passive sensors, okay, for the passive sensors, we actually what is the aim? What is the principle of the sensor? So we know resistance. Resistance changes with the temperature. That means it requires external power, right? If it's passive, right? Normally thermistor, thermistor, we need this is a passive sensor. But thermocouple, it is having its own energy, active sensor, right? in addition to that PN junction thermometer, we have to bias the junction, right? So otherwise signal amplification should be there, so it's passive type, right? Resistance thermometers, resistance is changing, so we need external supply. So depending on the situation, you should be able to find that whether it's passive or active, right? For your understanding only, all the things will not be evaluated in the examination, right? Even we are having this 24 sessions. We have limited sessions, number of sessions to evaluate. As I mentioned, first out of first 10 session, maybe 7 for cat, right? Cat one. I'll let you know everything later, right? Within the within this full sessions, I'll let you know, right? Inform you everything. Right. So then we can move to next slide. If you can go to the slides I have shared with you in oil emiss here, right? Conductivity of semiconductor and metal. Conductivity of semiconductor and metal. So metals, you can see here, the left hand side, you can see the metal and also the semiconductor. I'll share the slide, that PowerPoint animation, just to show you that animation. It's not, you all can go through that. I'll try to show you. Okay, now I think so. On whoever animation is not working properly. You can find it on yes. Actually, I have upload this everything to oil limit, so you can find that animation. So actually, this is in a metal. You can see these vibrations, right? And can anyone tell me the way what do you mean by this VB? What do you mean by VB? Yeah,
Valence band.
VB and VB. What is that? Valence band. Valence band. Yes, exactly correct. Valence band and what is the first one? Valence band and what the second one? CB?
Conduction band.
Conductance band, exactly correct. So you know, write it. Valence band mean in the semiconductor, it's like a crystal, silicon crystal. So electrons are in the covalent bonds in the ground state. So we called it valence band, right? But with if it's absorb energy, it's come to the conduction band, right? Absorbing energy. So just go through the just look at the animation as well, right? So you will see this energy gap, Eg, right, which shows the conductivity of the material, right? Conductivity of the material is depending on the energy gap, Eg, right? Energy gap Eg equals ECB minus, you can see that ECB minus ECB, Valence bond, right? Valence band mean that is the normal state, down, just say it's down state. So electrons are in covalent bonds in the silicon crystal, right? They are not free to move. No conduction, no electron flow when it's in the valence band. But if it's absorb energy and electrons are excited, getting excited, then move to the higher level, this free electron, it generate free electrons. So then because we know these are bonds, covalent bonds. Here we have covalent bonds, right? Right, covalent bonds. So electrons are there, 4 electrons in the outer orbit of the silicon atom. So if the energy is absorbed, what will happen? The energy is absorbed, electrons are releasing from the bonds and creating holes, and we have free electrons. So when it's come to that state, we call it conduction band. Electrons are in the conduction band. And also the difference between this conduction band and the valence band, so we can determine the conductivity of the material, right? Valence band, here conductance band, right? So that is the story behind the semiconductor material. We should know that. But when you come to the metal, you will see that image. Just look at that animation. So you'll realize how it's happening, how the electrons are bonding, attracting in the metal, right? So normally these sensors are made of semiconductor material. So then, these electrons releasing from the bonds, absorbing energy, right? If we have thermal energy, electrons are releasing. So we can identify the physical conditions, right? Thermal conditions. If the temperature is high, mean higher amount of energy will be absorbed to the semiconductor material, right? So if it's a thermistor, so thermistor detect the temperature. So that's the mechanism behind the sensors, right? So then we can move to the thermistors, right? Right? Thermistors. So thermistors are thermally sensitive resistor made of semiconductor, right? It is also made of semiconductor. If you look at the, if you understand this, you can see that if the thermal energy is absorbed to the silicon crystal, it will produce free electrons and move to the conduction band. Electrons are moved to the conduction band. So that is the way to produce the electrical signal, right? So we know resistance of a semiconductor decrease with the temperature. If I draw a figure, graph, right? Just say here the temperature theta and the resistance R, the y-axis. First one for the conductors, the variation of resistance of the conductor versus temperature. This one for semiconductors. Can you tell me how about the variation of this? resistance is increase or decrease with the temperature? For the conductors,
Increase.
resistance is increased. You know, yes, because of the collisions of electrons. Electrons are available in conductors. So conductors. So electron will collide with each other, and also electron will collide with the atoms. Free electrons are uh, colliding with each other. So because of that, the resistance will increase. But when you come to the semiconductors, the free electrons, the number is low, less amount of free electrons, not that much. If you consider cubic centimeters, 10 to the power of 10 per cubic centimeters is the free electrons and holes. So resistance will decrease with the temperature. That means the conductivity is increased. So that's what we indicate here. Resistance of semiconductor is decreased with the temperature. You can see this kind of graph we call negative gradient. That's negative temperature coefficient we have here, right? Right. Resistance and temperature relates. So we have a relationship between this resistance and the temperature of a semiconductor. This is the relationship, right? If you consider a conductor, we know the equation. What is that? R equal R naught 1 plus alpha t ta. Right? We will discuss it in the next slide, I think, right? So here we are discussing about the semiconductor device. So in the thermistor, the resistance is changing with the temperature according to this equation, right? This is the equation we should consider. We have RT, the temperature, unknown temperature, whatever, right? The resistance at the T temperature, and 0, R0, resistance at 0 degrees. So I think it should be 0 degrees. Zero power resistance. What does it mean? Zero power resistance. RT and R0 are zero power resistance. What does it mean? We are going to connect this. These are passive sensors, thermistors. We are going to connect with external circuit, right? We are going to apply power to the circuit. So in this case, if the power is connected to the circuit, we have to switch off and we have to apply zero power to the resistors. So zero power resistance means the resistance at zero external power. What is that? Resistance at zero external power. Right? Zero external power. Is that clear? Is that clear or not? ඔයාලට පැහැදිලි දෙයක නැද්ද කියලා මට පොඩ්ඩක් කියන්න බෑ. Any question? Just clear to you all, otherwise ask a question.
පොඩ්ඩක් සාබෝ කියන්න.
Right. ඒ කියන්නේ මේ RT ඒ කතාවද එකද?
ඔව්.
Right. Again, we know that we need external power for passive sensors. Is that clear?
Yes, sir.
Yes, we need external power. So thermistor also a passive sensor mean we need external power, but we are going to measure the resistance in between two terminal of the thermistor, right? So if you have connected the power source to this, is just say this is the thermistor. Right? Thermistor. And we have connections, right? Just say we have resistor voltage divider circuit here. We have a voltage divider circuit R and this is RT, right? So if you are going to measure the resistance, whenever you are applying the voltage source to the circuit, this resistance will be changed, right? But here RTR0 mean the resistance at switch off condition. This one off. So zero power is applied to the thermistors, right? RT and R naught are zero power resistance mean no power applied to the thermistor. Is that clear now?
Yes, sir.
If you have any doubt, just raise your question again. Doesn't matter. Okay. So this equation is not that much important. We are not focusing this equation, but I am trying you to understand this everything right in the slides, right? And can be this is the range we can use. This is the range we can use the where is correct here. Can be used in range minus 50 to 300. Minus 50 to 300. That is very much important. The range, right? Sensitive range. And variation of resistance 4% per 1 centigrade, right? Centigrade, 1 centigrade, just say it's 1 centigrade per centigrade mean 1 centigrade. So what does it mean? Variation of resistance. That means if you consider this thermistor, right? Just think about 1 degree centigrade change, right? So the resistance change. Discuss about the resistance change. Right? Earlier the resistance is 100. Just say it's 100 ohms. After 1 degrees of change, what would be the temperature? Resistance is decreased with the temperature. To say 1 degrees increase, what should be the resistance value of this thermistor? Can anyone tell me? Is the value given here? I'm asking that the just say resistance of the this thermistor is 100 ohm, right? Variation of the resistance is 4% per 1 centigrade. It's given here, right? So I'm asking if you are going to increase this temperature by 1 degrees, 1 Celsius, right? What should be the value, RT value? It should be 4% change. That means 4% mean to consider 100 ohms, it's 4%. 4% change, right? If it's 100, 4%, 4 ohms will be changed, right? So we know if we are going to increase 1 centigrade, it should the resistance should be reduced. It should be 96. If my calculation is correct, it should be 96. Is this clear? When you think about the semiconductors, when the temperature is increased, resistance should be decreased. If it's 100 and temperature is increased, mean resistance should be decreased. It should be less than 100 now. For 1 centigrade, 4% will be changed, reduced, right? So if it's 100, 4 should be reduced. That means 96. Is that clear? Is that clear or not? But here the percentage is given, but we can find these values using this equation, right? But, don't worry, this calculation will not be in the examination, but I just explain the things given in the slide. Is this clear or not?
Clear, sir.
So I think PN junction terminal, we can start next day. We'll start from this side of the north, right? Next day, second day, right? Day 2. We'll start from this side, and we are going to discuss about the different type of sensors, right? These are things we are going to discuss, and session number 3 also will be complete. 3 and 4 we're going to complete on next day in this rest of the part, right? So please go through the things that we have discussed. Especially we discuss about the data acquisition system and the element, others the parts. So actually components of the data acquisition system, transducers, especially we discuss about the transducers and the signal processing electronic circuits, right? Bridge circuit and also the potential divider circuit we have discussed. So these are the things we have discussed today, and you should be able to identify the active and passive sensors. Difference between the active and passive sensors should be understood, right? So if you have any doubt, just ask a question. Otherwise, we can stop the session. If you have anything, just raise it, right?